Did you know that airplanes typically have a mass of at least 41,000 kilograms? In comparison, the average adult has a mass of only 62 kilograms. So you may be wondering, how does such a massive machine soar up into the sky, traveling at over 900 kilometers per hour? To answer this question, we must consider four main forces acting on an airplane. Weight is probably the most obvious one. Contrary to popular belief, it is not the same thing as mass. While mass describes the amount of matter something has, or the amount of space it takes up, weight is the force of gravity that acts on this object. However, while mass and weight are not the same, they are related. The more mass an object has, the more it'll weigh. Okay, to demonstrate these concepts, let's consider an astronaut. Regardless of which planet, moon, or even spaceship this person is on, their mass will always remain the same. In other words, they will always take up the same amount of space. On the other hand, the astronaut's weight becomes greater when they are on a planet. Out in space, however, they have such little weight that they just float around. This is why they might be referred to as weightless. Nevertheless, astronauts are not actually weightless. The force of gravity is just so little that their weight becomes insignificant. Now let's get back to planes. As you may imagine, these machines are extremely heavy, and the force of weight pulls them down to Earth's surface. Therefore, to counter this, lift must be generated. Lift is a force arising from a plane's motion through the air. You might think that engines generate lift, but this is not entirely true. In fact, there are some planes, called gliders, that fly perfectly fine without having any engine at all. So how does an airplane experience lift? Well, most of this force arises from the design of the wings. If you look at one of these wings, you can notice that the top tends to be more curved than the bottom. As a result, air pressure below the wing is greater than air pressure above the wing. This means that overall, more force pushes up on an airplane, therefore causing lift to be generated. Nevertheless, for an airplane to experience lift, it must first be propelled fast enough. This is where thrust comes into play. Thrust is a force that is usually generated by the engines, and it pushes an airplane forward. For the many gliders that lack engines, thrust may be generated through other means. As an example, in the early era of gliders, a running person could push their plane fast enough for it to get caught up in the wind, thereby generating lift. The last force to consider is drag, also known as air resistance. This force acts opposite to thrust. In other words, it slows down the plane. For a better understanding, let's picture a beach. When swimming here, you have to push through the water. This requires a significant amount of effort on your part because the water exerts a force of resistance. Similarly, when flying, airplanes encounter resistance from the air. This is the force of drag. So, how can an airplane reduce its drag? Well, there are many methods. For instance, airplanes have a long, curved, and smooth design. Therefore, air around the plane experiences less disturbance, which reduces resistance. In summary, there are four main forces that are important when learning about flight. These are weight, lift, thrust, and drag. As you can see, weight and lift act vertically, where weight is directed down towards the ground, and lift is directed up towards the sky. And for the horizontal forces, we have thrust and drag, where thrust points forwards and drag points backwards. I hope you enjoyed learning about flight, and thank you for watching.